As the new year unfolds, I am revisiting my initial plans for the layout. Throughout the past year, I occasionally found myself veering off course with other layout control buses, diverting my focus from advancing the electronic aspects of the layout. Despite exploring various systems, I am confident that the path I had originally chosen is the most optimal for progress this year. In my humble opinion, CMRI stands out as the easiest protocol to integrate with Arduino, ESP32, or Pi Pico. The need for exploration arose when I decided to transition to a more localized module approach for the layout. However, after careful consideration of my position in the last few weeks, I firmly believe that sticking to my initial choice is the best course of action. While I will continue to explore and document the CAN bus side, mainly for a non-railway project, the C-bus project is temporarily on hold for the next few months. My focus for the upcoming 2 months will be on achieving full operational capability for more sections of the layout, alongside progressing with scenic work. I'm embarking on the initial task of creating a straightforward mimic panel for the layout's dock area. Previously, it was linked to JMRI through a USB connection, operating seamlessly. However, I've opted to eliminate the USB link, and instead utilize an RS485 module to establish a connection with the layout control bus. Within the dock area, there are 3 potential positions for locomotives. The first is designated as Dock Platform 1, highlighted in blue. The second is known as Dock Platform 2, highlighted in red. Lastly, we have the dock siding. There are 4 turnouts that we need to be able to control from this panel. T1 is situated at the Peel station area and controls either Platform 1 or 2. T2 is used to allow the train to enter the Peel approach area. T3 and T4 are linked as a crossover and allow access to the dock Platform 1 and 2, and also allows access from Platform 2 to the dock sidings. We have 3 red LEDs that represent block detection. These can be seen highlighted in red lettering. This may be a bit overkill, as I could simply turn around and check to see if the station platforms are occupied. However, I thought it would be fun to implement this in the panel. You could add logic to the system to stop you choosing the route if you wished. In the scenario where you intend to move a locomotive from dock Platform 2 to Peel Platform 2, the process is straightforward. Since we are currently situated on the red platform, you would press the red button corresponding to Peel Platform 2. This action triggers a message to JMRI, instructing it to activate the route and adjust all the turnouts to their necessary positions. The status of these turnouts will be visually represented by orange LEDs indicating their respective positions. Here you can see the Arduino, Nano, and the RS485 module. All that is missing is the 12-volt power supply to power it from the Arduino Shield power jack. In this spreadsheet you can see the information regarding the Arduino Nano node, for use in JMRI. You need to take note, we are using the baud rate of 115,200 for the communication speed. In the first row you will notice we have given the node a number of 25. For the dock mimic panel, we then have 5 columns, with the heading for holding the variable names, location, node number, event number, and Arduino pin. If you take a look at the variable name T1C, this represents turnout 1 closed LED, at Peel Station Platform 1. The LED will be controlled by a light table, in JMRI. JMRI will send out the state of the light using the event number of 25001, as either on or off. You must also take note when it comes to the inputs, the event numbers look the same, however they seem differently by JMRI. Hence D1 P1 has the same number 25001, but uses pin A0 on the Arduino. Here in the Arduino IDE, we can see line 29, we include the CMRI.h library. This does all the hard work for us. Line 31 we define the variable name, CMRI address as 25, lines 33 to 50. We define the variables to use for the various LEDs and push buttons.
In line 52 we give the CMRI library 3 bits of information, its node address, in this case 25, 24 equals the number of inputs and 48 is the number of outputs the module could have. Line 54 we start the void setup function. Lines 56 to 64 we set up the LED pins as outputs. Lines 66 to 70 we set up the input pins to use the weak pull-up resistors. Line 72 we set up the serial begin and set the baud rate to 115,200. Line 75 we start the void setup function, this will loop around continually while the unit has power to it. Line 77 we start the CMRI process running. line 79. This sets the state of the T1C LED, to the value received from JMRI in bit 0, which is 25,001 in this case. The lines 80 to 87 do the same for their LED states. Line 90 is setting the bit 0, to be sent to JMRI for the current push button state on pin A0. The pin is held at 5 volt when not pressed, so we use the exclamation symbol, digital red condition. If it not pressed it is ignored. Lines 91 to 94 does the same for the rest of the pins. Here you can see me testing out the panel, changing the routes. Also PL platform 1 is occupied. I will show the JMRI part in the next video very soon.